computers, maybe. So there are some, I will not go through these organizational notes because we've been over them for quite some time and they're here more for a pseudo-legal reason, like Vicky just said. But there are some additional organizational notes that I want to touch upon today. First of all, I don't know whether you've seen this or not on the CIP forum, but we decided to organize some office hours, and both Emma and Dieter have graciously agreed to spend some of their time on office hours. In case you have any questions on anything related to, LACIP or programming in general, or even maybe, talk about some other stuff. Here are the dates and times that Emma and Dieter will be available. Emma will start next week on Thursday, and we'll be doing this every Thursday until further notice. And this one will be in the morning Pacific time, so from 8 to 9 a.m., an hour. And Dieter will start the week after that. That will be on Wednesdays, and it's going to be Wednesday evening Pacific time from 8 to 9 p.m. So if you have anything that you want to discuss, questions, assignments that you have difficulties with, programming concepts that you want to, discuss or have explained to you, feel free to drop into these office hours. And once again, Emma and Dieter, thank you very much for your time. Also, this is something that we want to, reiterate, although we discussed this probably at the beginning of every session, is it's very important and helpful to watch lectures and slides and do the assignments in advance of actually having our session here, because that it's more useful. You will get more use out of our session if you try to get into the topic and actually try to solve the assignment in advance, even if you, for one the reason or another, are unable to do the assignment, or you're able to only partially do it. It will be a lot more helpful because you will know which questions to ask, what issues you had, so on and so forth. And finally, since Vicky did a questionnaire, a poll on a number of things pertaining to Life After Code in Place, one of the things that she asked about was the breakout room format, and we saw from the answers that it's not everyone's cup of tea. So for this reason, today we decided to give it a go in a different format. I will talk about it when we get to that, but yeah, bear this in mind. We will still do breakout rooms, but we will have options on what to do with them. And for the schedule for the next 4 weeks, today we're discussing 2D lists. Next week, August 20th, will be the final data science session, where everything we've learned before with Chris and Dieter will be put into one case study. So if you are interested in those, in that specific direction, if you've been following those sessions, this is sort of like the final one, the apex. And then at the end of August, we will have a session on strings, because there are a lot more to strings than we've actually covered in the initial Code in Place. And at the beginning of September, we will be covering files and working with files. So now I will pass the microphone to Vicky, because Vicky has some special quiz for us that even I am not aware of, but I know that the prize for the quiz is quite different from what we had before. So Vicky, it's your microphone.
Sorry. Okay, I wasn't quite ready, so I have to find this file. So, if you could, if you want to keep on talking so that we don't waste time, I will find my file and then let you know when I find my file, because my desktop is kind of a mess. I'm sorry.
Okay, so then for now I can talk about the the plan for today. So, like I said, today we're going to discuss 2D lists, but we will also talk about something which is called doc tests. The reason why we want to talk about it today, because the assignment, at least one of the assignments that we have today, actually uses doc tests. So it would be probably helpful to understand what they are before actually using them. And then we will have two problems. The first one is called zip to lists. We will do this in breakout rooms. Like I said, we will discuss the format a bit later. And then we will do the solution together in the main room. And then the second assignment that we will tackle is the so-called send assignment. We'll probably spend most of the time dissecting that one, although I feel that it's actually a bit easier than doing breakout or doing baby snake if you know how to approach it, because initially it might look very daunting, but in reality it's actually not that daunting, and it's quite an interesting assignment. So that's the plan for today. Vicky, do you want me to go on, or do you have something to work with?
Yes, I do have something to work with, except, I have to figure out how to share my slides without giving away the answer. So give me 1 second. Um, okay. Um, Let me figure out how to share this without giving away the answer. Hold on. Um, Alex, how do I share without like showing all my other slides? Do you know?
And you go in presentation mode.
Yeah, you have to actually open it full screen to the slide that you want to show, and then you share that
Right,
specific
but if
slide.
I open it full screen, it doesn't actually like, well, okay.
Nice to see another furry.
Right. I mean, so okay, so I have this, and then let me see. Okay. Okay, here we
Yes,
go. Okay. So
just all wear
There you go.
masks.
there we go. Okay. Sorry guys. Okay. So announcement number one, there is another Chinese soap opera that just aired with this guy, Yang Yang, which is my second favorite actor. So I hope you guys will support him. It's streaming on Youku. Okay. So the quiz I decided for March is I had like a very bad 2 weeks of lots of like unfortunate things happening to me. But yesterday, I think I got like really wonderful news. Okay, I got a huge grant from the NIH. And so I was like, it sort of like erased all the bad things that had happened to me for the last 2 weeks. So I decided for the month of August, for the next basically 3 or 4 lectures that's going to happen in August. Okay. Whoever gets this quiz right is you could have your pick for either like a SIP 2025 t-shirt or the equivalent value in an Amazon gift certificate. And I did not share any of these quizzes with Alex so that if you're an SL, you can also eligible to try to like enter. But these are not like really obvious places like the Kremlin or Washington, D.C. They're somewhat obscure. And so it is possible that nobody could win. Um, so for this week, I'm looking for three things. Okay. I want the name of this place, I want the city, and I want the country. And all three must be correct. And you can't like pick and choose from other people. You have to come up with all three. So the first person who gets this right can have their pick for either a SIP 2025 t-shirt or the equivalence of an Amazon gift certificate. Okay, so here's the picture. Okay, get ready. Wait, how do I advance? No. Okay. Oh, here we go. No, no. Okay. This place. I actually can't see the chat in this mode. So let me see.
If I see something in the chat, I'll let you know.
Okay. I see no answer in the chat. Oh, come on. This is very sad.
You mean the place that's on the screen, or the fact that we cannot say? You do know that you just showed the answer, right?
I know. So
So maybe someone saw it and they
It's Westlake, Gwangju.
There we go.
well, I mean, before I show the answer, there was no answer. Okay. Okay, so that was a bust. Maybe next time I will still tell like Alex to like incorporate it in his slides because obviously I'm not a slide guru. So anyways, I didn't think this one was this hard, but yes. This is Westlake, Hangzhou, China. Hangzhou is the birthplace of DeepSeek, and Westlake is known as the most beautiful lake in China and for its world famous Longjing tea. There are actually 10 scenic spots around the West Lake. Each has one of these like stone signs, but only two of them are from the original. And then you can tell they're from the original because they're walled off and fenced off, whereas like the replica, they don't have this fence. And then also on the opposite side of this stone carving, there's actually some calligraphy that's from the original emperor of the Qing dynasty. And whereas the replica, they're missing those calligraphy. And one of the most well-known scenic spots around the West Lake is this tower, the Leifeng Pagoda. And so it's associated with a very famous legend in China, with legend of the white snake. And so this tower, people used to like steal bricks from it because they think it's for good luck. So finally, enough brick were stolen. The tower actually collapsed in 1924. And so when they were rebuilding this tower and then excavating its foundation, they actually found a real white snake in its foundation, which I thought was kind of cool. But this place is absolutely beautiful. And so I hope all of you guys will have a chance to go and visit someday, especially during the spring. Okay, I will stop talking. And, next week we can try again. And I'll see if I can give away a SIP 2025 t-shirt.
All right, so thank you, Vicky. And let's get back to today's content. So the first thing we're going to talk about is 2D lists. And lists, as you remember, hopefully you remember, lists are ordered data structures with elements which are accessed by indices. So when I say ordered, it means that there is an order. Something is first, something is second, third, fourth, etc. And this order is represented by the indices, which are zero-based. So the first element has index 0, the second one has index 1, and so on and so forth. So if we had, for instance, a simple list of numbers like this, in the computer's memory, it would be represented, well, not like this specifically, but we could visualize it like, boxes with integers in them with indices. And when you create a list, the elements in a list can be of any data type. So they don't have to be the same data type. They could be different data types. Also, although this is rare, but you have this option. So for instance, you could have a list which has an integer, a floating point number, a string, a Boolean value, a non-value, and this is perfectly legal in Python, unlike many other programming languages where this is not legal. And this actually means that if we can have list elements of any data type, this means that we can have a list which has other lists as its elements. So for instance, here, if you look at this line of code, you have the outer square brackets which represent the list. And inside this list, separated by commas, you actually have 3 sublists. So you could visualize it like this. This is the entire list, or you would call it the outer list. And inside this outer list, you actually have as elements 3 other lists. So this is the list at index 0, this is the list at index 1, and this is the list at index 2. And they can be of the same size, they could be of different sizes, it doesn't matter. It could be the same value type, or data type, could be different data types. This is everything, this can be done. And these lists are known sometimes as simply lists of lists, or they're called nested lists because you have a number of lists nested inside the outer list, or they are called 2D lists. And the reason why they are called 2D lists will, I hope, readily become, you will understand this in a couple of moments. So basically, if we create a list like this, we could also visualize it in Python like this. Right? So you have, this is the first list, this is the second list, this is the third list, and this gives you a sort of matrix where you have list indices in the vertical column, and you have the indices of the elements inside those lists in the horizontal row. So you could visualize this list of lists or 2D lists like this. And now the question becomes, if we have this list, let's think for a moment. For instance, if I wanted to print the 0th index of this list, what would be the result? What would be printed on the screen? Can someone give me an answer? What would the resulting print statement output to the screen?
The first.
Yeah, Steve, if you're raising your hand to answer, you can go.
All right, I didn't see it. It would be the first element of this 1, 2, 3, 4, 5.
So yes, it would be the first element of this list, which
Of the outer list. Yeah.
Of the outer list, exactly,
Yes.
which is a list in itself,
Right.
which would look like this. So this would be the contents of the 0th index of our 2D list, the list 1, 2, 3, 4, 5. With the same logic, if we take a look at the first index, we will get the list 6, 7, 8. If we look at the second index, you will still get a list. It has only one value, but it would still be a list of one value. So you would have the square brackets. Now, for instance, if we understand that under the index 0, we have the list 1, 2, 3, 4, 5, and we want to access one of the elements of that list, and we know the index of that list. For instance, if I want to access the 1, I would also need to use index 0. So basically, if the list itself is at index 0 and I want to get to the 0th index of this list, I would have to write it like this. So basically, it means the 0th index of the 0th index of the list. So if I try to print this, I would actually get the element which is stored at the indexes 0, 0, which in our case is 1. So now a question to you. If I try to print list at indices 1, 2, what would be the element that gets printed out to the screen? Anyone, you can speak up or write. Okay, I see 8. 8. Any other thoughts? No, you would be absolutely correct. That would be 8, because the first index refers to the list here. That's the list 6, 7, 8. And index 2 of that list refers to the element 8, which is in the third position, which is the second index. Okay, so next question. For instance, if I try to do this, if I say the third sub-index of the second index of the list, what would I get? Any ideas? So I see at least two thoughts. Maybe it would be an error. Maybe it would be none, because there is nothing, there is obviously nothing there. The correct answer is that you would try to go beyond the indices that exist. You would get an index error in this case, because there is nothing stored at index in indices 2, 3 in this specific 2D list. So I hope you now understand why they are called 2D lists, because they are in 2D. And with the same logic, you could actually have 3D lists, because 3D lists are lists of lists of lists of elements. You can have ND. You can have 4D, 5D, 6D, depending what you're doing. Usually, 2D lists are the most common, but you have situations when you need 3D, maybe even 4D, though I don't think I've ever seen 4D lists in my experience, but what do I know? So often 2D lists have the same number of elements in every inner list, which actually gives you a matrix. So you have each inner list has the same number of elements. So for instance, like this, you have a list of 5 lists, and each of those sub-lists or inner lists has 7 indices. And they are all the same size, so you sort of get a very nice looking rectangle. And the reason why these are popular is because they can be used for a variety of reasons. For instance, here you have a 2D list which has 1s and 0s. And you would go like, but what is that? What does this represent? But this could actually represent, for instance, a maze in a game. So if you actually look at this matrix as if it were a picture, then you could look at the 1s as if these were walls, and the 0s as if these were a path through a maze. I know it's not a very interesting maze, but still the idea is that this matrix represents this somewhat simple maze to get through. But I hope you see the idea that using 2D matrices can give you, can visualize certain objects in your program, depending on what the program does. And I actually have here a bunch of examples where 2D lists could be used. So for instance, a chessboard. A chessboard is actually an 8x8 2D list, and each element of that list is either one of the chess pieces, or it's empty if there is no chess piece on that specific square. And we were discussing tic-tac-toe, so basic tic-tac-toe is 2D, but I'm sure you could have 3D, 4D, or whatever you come up with. So this one is a 3x3 matrix, a 3x3 2D list. Battleship is 10x10. You could actually have an actual mathematical matrix like the one here. That would be also a 3x3 2D list. More complex ideas, for instance, you could have a game world, which is basically a 2D game world, which each of the squares is an element in a 2D list. So, for instance, some squares have cobblestones, some squares have grass, some of them have earthen jugs, some of them have, houses, some of them have characters, etc., etc. So this is also represented by a 2D list. Or images. We discussed images, and you discussed images when you had the session with Vicky. And images can also be represented by 2D lists, because each image is a bunch of pixels, which are, they have an X coordinate and they have a Y coordinate. So that's also a 2D list. And for instance, in 3D games, instead of pixels, you have something which is called a voxel. So a voxel is a pixel in 3D. So that would be an example of using a 3D list to represent objects which are not on a flat surface, but which are in a volume. So they are in 3D. Or for instance, an example that many of you, I'm sure, use, a calendar. You can have a calendar as a 2D list where you have days on one side of the list and you have time on the other side of the list. So for instance, this is Monday, Tuesday, Wednesday, Thursday, whatever. And then you have 7 a.m., 8 a.m., 9 a.m. And that's basically a 2D list at the intersection. Each element is whatever you're planning to do on that specific time of that specific day. So as you can see, 2D lists are used everywhere, and they are a very useful construct to have in your programming toolbox. Since we have this construct, we should be able, as with any list, to iterate over it. But there is a bit of a difficulty in this case, because like you have a list and then you have a list inside the list and you sort of go, but how do we iterate over specific elements? Let's take a look at the two options, how we could do it. So once again, I will change the list to look a bit like this. This is easier to visualize. And then, for instance, if we want to iterate directly over values, remember in a simple list, in a 1D list, we can iterate over values by saying, for element in list. And here we could do the same, with the only difference that we would first go over rows. We would go, for instance, you could write for row in lists. And then each row would be iterated over one after the other. The first row would be 1, 2, 3, 4, 5. The second one would be 6, 7, 8. The third one would be 9. But in our case, we want to iterate over the specific values. I don't need the row itself. I need the specific values in that row. How do I do that? Well, I need to iterate again. Inside the first iteration, I need to do a second iteration. So this is a nested for loop where I go for value in row. So for instance, if the first row is 1, 2, 3, 4, 5, then I will iterate over the values in that row, which are 1, then 2, then 3, then 4, then 5. And if I do a print statement inside these two for loops, I will actually print out these elements one by one, because first I will finish the first list, 1, 2, 3, 4, 5, then the outer loop will go to the second list and I will once again iterate over the values 6, 7, 8, and then the last list, which has only one value, I will iterate over it as well and print it. So the result would be 1, 2, 3, 4, 5, 6, 7, 8, 9, separated by spaces because I have the space here. So that's one way of iterating over 2D lists. Second one is, as with normal lists, 1D lists, you could iterate over indices. So in this case, you would, for instance, go initially for y in range len lists. What would this give you? So if you take lists and you take the length of a list, it will return the number of elements inside our outer list, and the number of elements is 3. So we have this one as the first element, this is the second element, this is the third element. So we will get indices 0, 1, 2 with the range function. And the reason why I'm saving this into the y variable is because you have to understand, usually in geometry, x comes first and y comes second. But here, given the way that these are written, you first get the y, and only then, when you iterate over the inner list, you go over the values. So here, the indices of the values will depend on the length of the list. So for the first one, you will get from 0 to 4, the second one will be from 0 to 2, and the third one will be 0 only and nothing else. And then you can use y and x to actually print out specific values from the 2D list, separated by space once again. And here, once again, this is very important. You have to pay attention to where you have the x and where you have the y, because if you misplace them and you switch them, you will probably run into an error, because you will try to access indices in the outer list that do not exist. So for instance, here you have from 0 to 4, and at one point in time you'll start printing 1, 6, 9, and then you will run into the problem that there is no index number 3 and there is no index number 4, and you will get an error. So, but the result will be the same here, printed like this. And this is everything that I wanted to talk today about lists. I see, Vicky, you have a raised hand. And if anyone else has a question on this topic, this is the best time to ask them, either in the chat or via voice. I prefer voice, but if it's not possible for some reason, you can write in the chat. Vicky.
Yeah, so I have a couple questions, okay? Because when you talked about 1D list, you actually showed us, I believe, a third way to actually loop over a list using the enumerate function, which
Yeah.
combines the indices as well as the element, okay?
Sure.
I mean, I think just by extension, you could also do that with 2D list, yes?
True. The answer is yes. You could do that with 2D lists. You could use enumerate in one or in both of these loops if you do need the values and the indices at the same time.
Yep.
The same logic applies. I just decided not to include it, not to overburden,
Sure.
I think, some minds which are already a bit overburdened.
Sure. And then, excuse me, can you go back one slide to the slide before where you were looping over elements? Yeah, that.
This one.
Yeah. So, I just wanted to sort of clarify, maybe for people, I'm trying not to confuse people. Okay. So, when you write a nested loop like this, and then you're iterating over a 2D list, okay, regardless of what variable you call, whether it's a row or column or value, okay, regardless of what you call these variables, okay, the first nested loop will always be looping over the outer list, correct?
Well, not the nested loop, the one that you actually have. The nested one is the second one. So the first one, the
Yes.
top one will iterate over
The first
list.
loop, okay, where you're talking about for row in list, okay, even if you don't call it for row in list, even if you called it like for column in list or for X in list or for A in list, okay, Python will just automatically loop over the outer list. Whereas the second line for value in row, okay, no matter what you call that, I mean, you don't have to call it value. That's where it will actually loop over the inner list, right?
Exactly. And it's logical in the sense that if you are in the first for loop, you are iterating over elements of the list, then there are three elements. So these are the ones you're looping
Correct.
over. There is nothing else to loop over except these sublists.
Correct.
And then the second one takes each of those sublists and loops over its elements, which are in our cases specific integer values.
Right. And then, sorry, one last question. Can you advance to your next slide? Yeah. And so here, okay, what I tend to remember, if you don't quite remember whether you're looping over indices or elements, is I always look for this like len term. Whenever I see len, that triggers me into thinking, okay, I'm dealing with indices and not elements. And then again, Alex, here it doesn't matter what you call y and x, right? Even if you were to flip x and y, that first line, like for y in range len, will always be referring to the outer list.
Yes, exactly. So the reason why I'm calling them y and x is to be clear what they are.
I know.
But you can call them whatever you want. You can call them A, B. You can call them foo bar. It doesn't make any difference. The order of iteration will always be the same. First the lists, then the values in those lists.
Yeah. Okay. Thank you.
Okay, Steve.
Just briefly, because that confused me a little bit. What we're calling rows, what we call rows, you're calling is the y value. Even in the other problems, the y value is the row, the x value is by default the column then.
Yes.
Is that correct?
Okay. Absolutely.
Because that confused me a little.
So the only thing that you have to bear in mind, like I said, that the y and the x are switched places for the simple reason of the way we actually visualize those lists. That's the only why it happens like that.
Okay, thank you.
Okay, any other questions on 2D lists before we go into doc tests? All right, so let's go into that. But if at some point in time you do understand that you have a question, feel free to ask. I'll be more than happy to answer. So doc tests. What are doc tests? I mean, many of you probably have never heard of this term. So let's discuss what are we actually talking about. A doc test is a very simple testing mechanism in Python, which allows you to actually embed test cases that you want to make sure are working within a function docstring. And here I'm certain many of you are like going, but Alex, what's a docstring? The fact that you've been using them, it doesn't mean that you actually know what a docstring is. So I will remind you. A docstring, which is short for documentation string, are the triple quote multi-line strings at the beginning of a function definition that document its functionality. Remember when we did Carol back, at the beginning of CIP, and we were told, like, guys, if you do a function at the beginning of the function inside triple quote strings, write what the function does. And that is basically a docstring or a documentation string, because it helps you understand what the functionality of that function is for anyone who is reading your code. It could be you 6 months later or a different person. And here's an example. This is a very simple function, a function which is called isEven. You pass number as a parameter. And this function has a docstring because at the beginning you have the triple quotes. And it says this function returns true if number is even, otherwise it returns false. So it's a very simple function. If you look at the code itself, you see that that's actually the case. If you divide the number by 2 and it gives you a remainder of 0, it means it's an even number, you return true, otherwise you return false. So this function has a docstring. It does not have any doc tests yet, because that's what we're going to discuss next. How can we use these docstrings to actually test our code? In order to do this, you would require the doctest module. So you would actually need to write import doctest at the beginning of your program. And what it does, it searches the docstrings in your file for lines which resemble Python's interactive prompt, which looks like this. It's like these 3 triangular brackets. And then it executes that code, which follows these 3 triangular brackets, and compares the actual output of that code with the expected output that you provide as the programmer. And if this sounds like gibberish to you, worry not. I will show you a very specific example so that you understand what I actually mean by this. And these lines, by default, they provide both documentation, since it's a docstring, and also they give you some testing capabilities. But there are different ways of using them, but the sort of most basic, in my opinion, way to do it is to actually include this line, doctest.testmod. This is a function which actually runs the test. And here's an example, going back to our isEven function. So as you can see, the docstring, the first 2 lines are the same. It explains what the program does, but then you actually have this line which starts with the 3 triangular brackets, or the more signs. You have a space, and then you sort of call the function. In our case, you, for instance, call isEven42, because you as a programmer know that if this function is passed the number 42 as a parameter, it has to return true, because that is an even number. And in this case, you write here true. So your function has to return true if you pass 42 as the parameter. Also, if you pass -13 as a parameter, it should return false, because -13 is an odd number, so it's not an even number, it should be false. And obviously, this is a very simple function. You would probably say this function is so simple that you do not need to test it, because it's very obvious whether it works or not. But, it's always good practice, even for simple functions, to do doc testing. And then when it comes to more complex functions, where sometimes you're not sure whether your code is working correctly, and you want to test different, your ideas of, what result you should be getting when you're passing this or that parameter. And I will actually show you an example. I will go now into PyCharm. Please let me know, do you see my PyCharm right now? Did it change to PyCharm on us? No?
No.
Okay, let me change this. Give me a second. Because I've prepared a small file which actually has a couple of functions. Let me make it a bit larger, like 32. There we go. So as you can see, I have import doctest at the beginning of the file, and then I wrote two functions. They are very simple functions. So the first function is called add numbers. It accepts two parameters, and it's quite logical. It has to add these two parameters together and return the sum. So this is explained in the docstring. But then inside the docstring, I have several tests. I have, if I want to add 13 and 42, I should be getting 55. If I add -7 to -14, I should be getting -21. If I add 0 to 0, I should be quite logically getting 0. So these are my test cases. This is what I assume as a programmer has to happen when my function works correctly. Then I have here the body of the function. So this is what I wrote, for instance, as a programmer. And some of you have probably noticed that this one is incorrect. So I made a mistake as a programmer when I programmed even this simple function. And now I have the ability to actually test it. So if I launch this program, I will get a number of errors. So at the bottom, I will actually, it will say that add numbers actually had 2 failures out of 3. So 2 of my doc tests failed and 1 of them was successful. And most of you will probably guess the reason why, but let's take a look. It actually gives me very specific situations. It says, when you tried passing 13 and 42, you said that the result should be 55, but the actual result I got was 546. So that's obviously 2 different numbers, something is wrong. And then it gives me the second one. You expected -21, but you got 98. So that one is wrong as well. But notice that the third one, which I have, where I have 0 and 0, it's not in the error list because, I will get 0 even in my incorrect code. So this makes you understand that, your function could work on some cases, but not on all cases. And this would mean that your function is still buggy. So I'm going like, whoa, what's going on with my function? How could I screw up so badly? I look at the code and I go, oh, okay, I have the wrong sign here. I actually need the plus here instead of the multiplication. And now that I have the correct code, if I run this program again, you will see that I do not have any errors for this specific function. It's now, everything works well. But then I have a second function here, which is called isEven. We've just discussed it. And I put in the exact test cases that we had in the presentation. And here is my code. And this code is already, it looks a bit more difficult to read. Like, what did I write here? What does it mean? I have to return true if I divide a number by 2 and I get a remainder of 1. Otherwise, I have to return false. And I have a bunch of errors. It says like 3 out of 3 of your test cases are incorrect because you state that 42 should be true, but in your case, for some reason, it's false. -13 should be false, but it's true. 0 should be true, but it's false. And I'm going like, maybe, I mixed something up. Let's take a look at the code. Oh, of course, if I want an even number, I have to look for a remainder of 0 and not of 1. And this should fix my code. Let's run it again. And now see, I run my code and I actually don't get any errors. So this means that all of the doc tests did their work and they passed with flying colors. So I do not have any errors, at least according to the test cases that I wrote myself. This is very important to understand that doc tests cannot check cases that you as a programmer didn't provide. It only checks the cases that you as a programmer understood have to work like this. If you forgot about some edge case and it has a bug in it, doc tests will not know about it until you write that specific edge case into your program. So, and this is the final line 35, is the way that this entire testing suite was launched. So if I comment this one out, nothing will happen in terms of testing. So you need this line at the moment in your program when you actually want to check each of your doc strings for these doc tests and perform them. So I think this is it about doc tests. I see, Vicky, you have a raised hand, so shoot your question and let me, meanwhile, go back to the presentation.
My question is, okay, when you launched your program, your
Yes.
doc test seemed to run automatically, okay? Whereas I think in the starter code that Miran had provided, he actually talked about like in order to launch or or run each doc test, I forget what he said exactly. You have to I guess like hover over those like
Yeah.
three
There are,
three
like I said, there are different ways of how you can launch doc tests, and I showed you the one which I think is the easiest one to do. But for for the sake of being complete in ways how this could be run, let me once again share my.
so I guess your doc test just launched automatically because you had that doc test phrase.
This one,
Yeah,
yes.
that.
This is the reason why they
Okay.
are launched in my case.
Okay. That's all I
As far
wanted
as
to
I know, in PyCharm, you can actually right-click on the test that you want
Yes,
to
yes,
run, and you
yes.
have here Run
Yep.
Doc Tests. So if I run this, it will give you a similar result. So let me make it incorrect once again, so that we actually have some result. And as you can see, I ran the doc tests, and I do not need this one. I can comment it out, and it will still do its job. So Python knows how to, though, does it? Huh? No, let me try it again. Run doc test. No, I don't think. No. This is the wrong one. That's not the one. That is not the one. It's just running the file. Hold on. Go to refactor generate. I actually don't remember now. I understand. I don't remember how to launch doc tests from Python, because I thought they would appear like this, but for some reason they don't. Okay, maybe here test. Let me check. No, this is something different.
So,
I frankly I don't remember right now because I don't use that option that often.
according to the assignment, you can run a doc test by right-clicking on the test text and selecting the run doc test option from the menu that pops up.
Yeah, but here, so that you understand, the phrase run doc tests means run the file, because that's the name of my file. It has nothing to do with doc tests. I can do it for a different file, like in zip list, and it would say run zip lists. So that's the problem. I seem to remember that that PyCharm has this ability to run them, but I do not remember how to do it. Maybe, I don't know, maybe someone else, maybe Emma or Dieter, maybe you remember how to do this, and you can share, because I don't.
I just sent a comment. This is how I do it in the main program, basically. If you don't want to run the program, just look at the functions. You can run the doc test mod, which is what you've done, or you can actually call in the individual functions, which can be useful when you have a lot of stuff to work on.
And you want to check a specific one, yeah. But basically, this is the same logic, because that's the one I use by using test mod or a specific function, yeah. I do remember it being an option somewhere in PyCharm, but right now, I cannot remember how it's done. So this is the way, for instance, when we're going to do zip lists, this is the way I propose to do it. you have to import doc tests, and at the end write this line doctest.testmod with the parentheses, and then any functions in your file will be tested. In your case, like when we do zip lists or whatever it's called, there is only going to be one function, and that function will be tested according to the doc tests, which are here. So you can see them here. This is the first one, this is the second one, this is the third one. So there are 3 doc tests which are included in the file already for you. And you can write your own ones. Andrew, I see your hand raised as well.
Where in PyCharm is the library imported and is it built into PyCharm?
No, the doc test library is part of the basic Python package. So if you have Python installed, then you have the doc tests library in it. If you just write import doc test, it will import it. There is no need to install anything different.
Okay, thank you.
No problem. Any other questions, thoughts on the subject, or shall we actually try it out in zip lists and see, how it goes?
Just one clarification. I think in the zip list file that we got, I didn't see any references to the doc test or import. I saw the tests in the doc string, but no place where it actually called the doc test test mod. So I ended up commenting them out because I couldn't figure out how to turn it off.
Okay, yeah, like commenting them out is an option, because I'm not sure whether this is actually the original list or I added these lines, because here there is the usual if name equals main. It actually has the doc test mod here, but I might have put this in here myself when I was testing them, so I don't remember. So you do need to include this one, and you do need to include this one in order for it to run. If you want your program not to run any tests, you just need to comment this out, and this will give you the desired result.
Yeah, I couldn't figure out where it got added in so that I could stop it.
Okay.
Yeah, I still can't find it. So if anyone else can find where it was or figured out how it got added in, please put it in the chat.
You are talking about the original file, which is in the
in the assignment.
Wiki put out. Okay, let me just open it just to see what it looks like, and maybe I'll give you an answer.
And you're not sharing, by the way.
I'm not yet. There is nothing to share at the moment. I'm trying to download it, so to see whether it's different from the one I have right now. So give me a second. I'll open it.
Yeah, that was a fun adventure. A little Easter egg.
As usual.
Where is this coming from?
Okay, so yeah, let me share my screen now to the file that I have at the moment. Let me first figure out how to stop. Am I sharing anything right now?
Oh.
Okay, no. So 1 second, which one is this? Zip lists? No. Where is it? This one probably. Okay, so this is the original file. This is the original file downloaded from Wiki's Google Drive, and there is actually I don't see anything here which actually calls the tests. So it means I added them myself manually. So if you actually run this program, I don't think you'll get anything. So let me try running it. Yeah, it doesn't give any test results in its.
So somehow when maybe it was imported someplace else in the project, because
could be.
Maybe in the sand code. I don't know. Okay, I'll look. Thank you.
Okay, no problem. So let us get back then to the presentation and actually discuss the first problem that we're going to work on and where we can actually test this functionality. So the assignment that we have, it's called zip2lists or zip lists, whatever, it doesn't matter. And the assignment itself is that you have to implement a function which is called zip lists or zip2lists, which takes in two lists of strings as parameters. These two strings of lists are the same length, so both these lists have the same number of strings in them, and it has to return a new 2D list, which has sublists of pairs of elements, one from each of the original lists in order. So this, once again, this sounds like a mouthful. It's a lot easier to explain this by looking at an example, which I'll show you in a moment, but it's important that the original list should not be changed. So you should create a new list and return a new list. And if you get past two empty lists, the result should also be an empty list. So here's an example of how this function would work. For instance, let's say we have one list which is called adjectives, and we have three strings in here which are funny, stupid, and silly. And then we have another list which is called names, which also has three elements, which are the names Bunny, Cupid, and Willie. And if we run this function and pass these two lists as parameters into this function, I forgot, by the way, the second closing parentheses, so that's on me, and then print the result, the question is, what resulting list are we supposed to have? And the result would look like this. We would have a list, this is the outer list, which inside it has three inner lists, which have pairs of elements put together in that list. So for instance, the first list would have two strings, funny, bunny. Then the second inner list would have, once again, two strings, stupid, Cupid. And the third one would have silly, Willy. So basically you take one from the top, you take one at the bottom, you put them into one list, and then you add them to the overarching outer list. So that's the way the end result should look like after you run this function. And we will now work on this function in breakout rooms, unless someone has any questions that I will answer before we head into breakout rooms and before I actually tell you how we're going to go about breakout rooms today. So any questions on what we're supposed to do? Because if not, then here is the story with the breakout rooms option. It's obvious that different people, get a different kick from using breakout rooms depending on whether they have actually done or not done the assignment before joining our session. And some people like doing it in groups, and there are people who prefer to do it themselves without, their peers. So we will have several options to do this today. We will have one breakout room which will be called completed. That would be for people who actually completed this assignment prior to joining the session, and you could go into the breakout room and discuss how you did it, and maybe think about ways of optimizing this function. Because actually, I think you can do this function actually in one line. It would be a very long line, but it's doable. Those of you that did not complete this assignment, whether you didn't even try to do it or you tried to do it but couldn't finish it for whatever reason, we will have a did not complete breakout room where you can actually go and together with your peers try to solve this together. We will have several rooms with this name, so you could break up into smaller groups. So Vicky, will they be like completed 1, completed 2, and did not complete 1, did not complete 2, or
Yeah, so currently we have room 1 is completed, and then people could see that. And then we have 3 rooms that are not completed. We're
Okay.
making some assumptions, obviously. And
Sure.
so if there are more people, who have completed the assignments, we can easily change a non-completed room to the completed.
Okay. So, and the third idea, if you want to work on this individually, you do not want to join any breakout room because for whatever reason you don't see the value, you can do this individually. You do not have to join any breakout room. You can stay in the main room with us and maybe ask questions, discuss something, or just turn off your camera, turn off your mic for 15 minutes and come back when we're going to solve this one together. So those are the three options, and you will be able to select a room yourself. So we're not going to automatically divide you between rooms. You will have to press the breakout rooms button at the bottom of Zoom and choose the room that you want to go into. So it's your choice because we don't know what your preferences are. Steve, I see your raised hand. You have a question.
Okay, this is maybe a pedantic question, okay? I did this code, I completed it. I ran all the tests manually because that doc test didn't work right because it kept throwing an error message. But all the sample code I did on another window and it all worked. So was it completed or not completed? That's my question.
It's your judgment call. I
Okay,
mean, you can select
said it was
whichever
pedantic.
one you think that applies to you. If you think you
Okay.
completed it, you can go to complete it. If you did not, you can go. It's really, it doesn't matter for us. Pick the one that you're more comfortable with.
Alex, the one other thing I would add is no matter which breakout room you choose, whether you want to work alone in the main room or whether you go to the completed, there will be an SL. And so you're never gonna pick a room where you're just like flying solo with no SL support.
Okay, excellent. So,
Okay, I'm
any
gonna
other
open the
questions,
breakout room now. Okay.
or shall we? I think, yeah, let's go and solution to this assignment. Let me share my screen. Let me share my pie chart for you, and let's go through it quickly. So, I suppose we all remember the assignment. So I'm not going to go through it once again. So we just need to write the code, and I was in the room with the completionists, so the people that wrote the code before the assignment, and we actually looked at code and discussed code written by different people, and we came to the following conclusion. So basically, if we need to return some list initially, like at the end of the function, if we need to return some resulting list, we should create that list. So for instance, let's call it zipped list. And initially, this zipped list is empty. We don't have anything to show. And at the end of the function, we will actually have to return this zipped list. But before we return it, we need to perform some magic. We need to put two lists together into one list of lists. And we do this by taking one value from one list, another value from another list, putting them together into a small two-value list, and adding it to this UBA list, the large list, the outer list. So the way we're going to do this is we're going to iterate over the indices of one of our two lists. It doesn't matter which one, because they're both the same length. So the way I'm going to do it is I'm going to go for I in range len, and here I can take either list 1 or list 2, it does not matter. So this will give me the length of the list. In our case, for instance, in this doc test, it's going to be 3 here, it's going to be 3 here, doesn't matter. And then range 3, it's going to give us the values sequence 1, 0, 1, and 2. So these are going to be the values which are added into the variable I. And then what I need to do is to actually, let me create so that it's clearer, I'll create something which I'll call sublist. This sublist should contain two values. The first value, let's call them A and B, for instance. And which one is A? A is what I'm going to take from list 1 at index I, and B is what I'm going to take from list 2 at index I. So here I have one value, for instance, it's A. Here I take another one, for instance, it's D. Then I create a sublist of these two values. So I have a sublist which has A and D in it. And the last thing I need to do, I actually need to append it to our zipped list. I'm going to append the sublist. And I'm going to do this again and again until I go through all the indices in our two lists. Obviously, this is a very long way of writing this code. I've done this to make it clearer. Of course, you can make this shorter. So if you understand what is what, you can actually take this and put it here. You can take this and put it here. So now we're, 2 lines shorter. And since this is sublist and this is sublist as well, we can actually take this from here, put it here, and now we have only 1 line of code inside the inside our loop, and we go over it again and again until we get the resulting list. So if we run this, we get a bunch of get a bunch of errors, and I'm not sure. It's for a different. It's running for a different. It's running a different program. Let me not doc tests, but current file. I'll run the current file. So we can see that it's giving me the correct result. So we have A, D, B, E, C, F, but we can actually check this using a doc test. So let me add a doc test in here. I'm going to import doc test. And inside main, before printing the result, I'm actually going to check it. So I'll go doc test dot test mod parentheses. And if I run this, you will see that I do not get any errors. But let's actually, let's actually try to do this incorrectly. Instead of, I will do something, stupid here so that it outputs the incorrect result. And if I run this now, I will actually get, okay, I forgot to close this. As you will see, all of my doc tests will fail because it says this is what expected. Instead, you just get this weird stuff. Instead of 1, 2, you get 1 error. Instead of an empty list, you still get an empty list. So 2 out of 3 are incorrect. So this shows that my doc tests are working. If I revert to the original, oh, come on, there we go, and launch it again, you will see that no errors pop up on the doc test. So any questions on this specific assignment that maybe you have concerning this solution, or the solution that maybe you discussed in breakout rooms, or what have you? I'm happy to answer any questions before we move on to sand.
One quick comment, and then just to whet people's appetite. Okay, this program could actually be written in a 1-line code using list comprehension, which we will talk about probably a couple sessions down the line.
We were actually talking about this, and I said that while it could be written in 1 line, I did not mention list comprehensions, but we were talking about the beauty of well-written code, and I don't think that writing this in a list comprehension would look like very readable code. So I would actually urge against writing this in 1 line. But yes, it could be done. Vicky is absolutely correct.
Well, this is actually one of the reasons why I decided to help Alex run code in life after code in places, because I never understood list comprehension. And so maybe I'll understand it this year, and then I don't need to take life after code in place anymore.
Again, we will most certainly discuss them because I like list comprehensions. Sometimes they are very nice looking, very crisp looking. So any other questions, comments, anything? Okay, if not, let us talk about sand. And I don't mean talking about actual sand, I mean talking about the assignment, which is called sand. Let me share my screen quickly. Okay, so in the sand assignment, it actually looks like a quite difficult assignment for the simple reason that it has, a graphic interface where you have an actual application which you need to work with. So it might be very off-putting, because you would go like, we didn't work on this, we didn't learn how to write applications. But the thing is that the application is actually pre-written for you, but it doesn't do anything, because, well, it actually does. You can draw sand, you can draw rocks, but nothing happens, because in its initial state, this application is dead. It does not have any functionality in it, which the program should have. The nice thing about the sand problem is that it's actually broken down into small functions, and this is the way it should be done for any large program. It should be broken up into small functions, and each function is supposed to do one very specific thing, and it should be easy to program because it's a very one specific small thing. And if you look at this problem just like that, you cut it up into small slices and you solve one small problem at a time, it's actually quite a fulfilling assignment, because you sort of do small assignments one after another, and then suddenly they turn into a working program, and you go like, wow, I wrote that and now it works, and now I have a simulation of sand falling from the sky and into neat piles, etc., etc. So the series of functions that we will have to write today, the first one is a function which actually moves a grain of sand to a new location. So you have it in one location, you have to move it to a different location, the function has to do that. The second one is to actually check if that move is legal. There are several things that we need to bear in mind, which moves are legal and which are not. The third one is you have to actually apply gravity to a grain of sand. And what that means, like, gravity is actually moving downwards, because that's the way gravity works. But there are several ways how the grain of sand could move, depending on whether there is something blocking the movement under it or not. And then the fourth function should put all of this together and process all the sand in the world. So you have many grains of sand in the world. Each of those grains of sand should have gravity applied to it. And then you would have an entire beautiful picture of sand falling down. There is also an optional bonus function. I don't know whether we'll be able to do it today or not, though actually it's not that hard to do. It's to apply some Brownian motion. If you know a bit about physics, Brownian motion is what you get with tiny particles. So for instance, in water, if you put tiny particles in water, you will actually see that water's molecules make those particles jump back and forth in seemingly random way. It's very hard to predict Brownian motion. And here we have the same. We can do Brownian motion on sand. So it's not like predetermined the way it's going to fall, but it actually has like small minute movements that are random each and every time you run the program. So it gives you a bit of flexibility of how your program works. So these are the 5 functions which we need to write. And I will now exit the presentation and go into PyCharm. And meanwhile, once again, if there is something that you do not understand about the assignment, obviously it's a lot more difficult to understand it if you haven't actually read it, because it's quite a large assignment. So this description that I just went through is for people who at least read through the assignment before coming in. Otherwise, yeah, you'll have just to look and see what the application looks right now. So give me a second, I will pull it up. I will share my screen as always. I will make the text larger so it's easier to read. So as you can see, the file is actually quite large, but that shouldn't be a problem because most of this file is pre-written for us. So everything which is below line 139, we do not need to understand how it works and why it works. It just simply works. So we need to work on the 5 functions which is above. So that's 1, 2, 3, 4, and 5. And you might be a bit scared of the amount of text which is in here, but actually most of this text is doc tests. So you can see that these are all doc tests. And here is the doc string, which actually explains what the function has to do. And we can actually run this program right now. So if I press play, we will get an application. So here is this application. And there is nothing on the screen. It just looks like an empty slate, but you can actually draw stuff on it. For instance, you can draw grains of sand. So this is sand. But as you can see, unlike in the real world, here sand just stays put. It doesn't fall down because we have not written the code to actually apply gravity to the sand.
Alex,
also, we
can't see the sand window. We can only see PyCharm.
Okay, I'll have to do this differently because otherwise it's going to be difficult. Yeah, thanks, Emma, for pointing this out. No, this is not what I want to share, I guess. Okay, let me try this once again. Do you see the application now?
Yes.
Okay, good. So once again, here is the application. I can draw sand. So here is sand, 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 sand. It's not going anywhere. I can draw rock. It's not supposed to go anywhere. So that function at least works. Rock is not falling anywhere. But once we are done with this program, the sand should be falling down into piles depending on, what rock we have. Or for instance, we have a hole here like in an hourglass, and then the sand is supposed to fall through and form a pile here because that's the way, sand behaves. But right now, it's just a static dead picture. So let's close it. And let's go and look at the functions that we're supposed to write. So the first function is called doMove. And what it says we're given a grid, and a grid is a 2D list. So this entire world is essentially a 2D list because each of these grains of sand and each of these pieces of rock has a coordinate, an x coordinate and a y coordinate that are represented by a 2D list. So we have a list which is this many elements in each sublist, and this is the number of sublists. And each of them contains something, an element which says that it has a rock, or it has a grain of sand, or it has nothing. And in our case, if you look at this, you will see that rock is represented by the letter R. It's the small letter R. Sand is represented by the small letter S. And emptiness is represented by the none value, which means there is nothing in that specific spot in our sand world. So we are given a grid. So the entirety of the world in this grid parameter, this is the 2D list. And we are given 2 coordinates. First, we have the x and the y coordinate of the location from which we want to move something. And then we have x2, y2, which are the coordinates of the location to which we want to move something. So basically, the function says inside this grid, takes whatever is it, x1, y1, and move it to x2, y2. That's what this function is supposed to do. And then return the resulting grid. So the grid will change because of this, and we will need to return the resulting grid. The important thing is, it says here, assume that this is a legal move. So you can actually move from this coordinate to this coordinate. Do not, at the moment, we should not be thinking about whether this move is legal or illegal. We should assume that this move can be done. And we'll talk about the legality of this movement in another function. It says here there is a different function which we'll check for this. And we have a bunch of doc tests. So let's take a look so that we actually understand what the doc tests mean, because at the moment they may look like gibberish. So we need to figure this out. And Andrew, I see your raised hand, so shoot me if you have a question.
The grid is a specific location on the canvas, the coordinates, or it's all relative to previous coordinates, so to speak.
No, it's absolute coordinates. So if we wanted, we could actually calculate the number, of spaces we have on the x. So we could actually calculate this and say, like, I don't know how many, but maybe like 40, maybe 30, and then we could calculate the number of rows, and we have a very specific grid of this size. So this is the size of our grid. It's no more and no less. Does that answer your question?
Yes, it does.
Okay, excellent, excellent. So, and we get a representation of this world as a 2D list. For instance, here in the doc test that we have a very small world. So you see here is the representation. It's actually only 2 sublists. So we have a 2x3 world. It's a very, very small world, only 6 pixels. And here we have the top row. We have rock, then we have a grain of sand, and then we have one more time, a piece of rock. And then the second row is once again rock and empty space, and once again rock. So in this case, if we were to try to move something from coordinate 1, 0 to coordinate 1, 1, this is 1, 0, in the sense that remember that x and y are switched places. So this is not x, this is actually y, and this is not y, this is actually x. No, sorry. Here they are written in the usual geometric order. So here 1 is supposed to mean x1, so the second element of the first row, and here it says move it to the second element of the second row. So what it says, it's move this element here. And if you look at the result that the problem expects, you will see that now instead of S we have none, and instead of none we have S. So the grain of sand moved from this location to this location. Then we have another one, which is a different world. It's also a small world, but we have, rock and 2 sand in the first row, and we have nothing in the second one. Once again, if we move the same grain of sand, this is the result that we're supposed to get. So now we have none here and the grain of sand here, and etc., etc. So now my question to you is, if we know the grid, if we know the coordinates from where and to where we need to move something, and whatever it is, it could be, for this specific function, it could be sand, it could be rock, how do we actually do it? And this is a question to you guys, so that you actually participate in the discussion. If we have this information about the world and we need to move something, how do we actually perform that movement? Any thoughts? Yes, Steve, let's go.
Okay, actually, this is Vicky. I'm sorry, I just got your name again. This was in Vicky's video about interchanging elements in lists, and that's what I use, and that's what works.
Okay, so let's talk about it. How would it work?
So, okay, let me go. Now, I think I have this code. I didn't lose this one.
But I don't want you to read code to me. I mean,
okay. So what I did, okay, then I had created one temp variable with the x2, y2. Let me get this right in my head now. With the x2, y2 indices, right?
Yeah.
Then I use the same indices again, changed it with the x1 and y1, and then the last part, I changed the x2, y2 back to the temp.
Okay.
And then
So you basically you switched
Yeah.
the contents of these two cells.
Right. Yeah.
Ah.
Okay.
But my question is now, let's think about it.
Yeah.
But in reality, is it about switching places or so let's think. If, for
No.
instance,
Sorry, not switching places, switching the elements.
in those locations. Yeah, I
From
understand.
that one location to that one and that to that one.
Right,
Or that
right,
one's that
right.
one, that one's the other one.
Right. But I mean, let's take a look at it from, normal world logic. You have sand falling from one location to another location. So it's logical that the sand from the first location ends up in the second location. But is it true of the opposite? Does it mean that the actual contents of the second location move to the first location in the real world?
No, not in the real.
Okay, so what happens with the first location in the real world?
I have no idea.
But I mean, for instance, you have a piece of sand in a location and then it falls down from that location. What remains in that location?
They both remain in that location. I don't know, really.
It becomes
Got me
empty.
confused now, Alex.
But nothing remains. If something falls from a
becomes empty.
location, nothing remains in that location.
Oh, that's true. Okay. Yeah, all right. Nothing remains.
So that location is left empty. So the reason why I'm saying this, though your code would work, because in this specific case, you would actually be changing sand for nothing and nothing for sand. But in terms of understanding the logic, it's actually easier to simply move the first one to the second one and then say there is nothing remaining in the first one.
Yeah, but that's kind of what I did because I assumed nothing is none.
Right, exactly. But you assume that every time there will be nothing in the second location. So you're not thinking about, for instance, a situation when there is water in the second location, and suddenly you have water going up to where the sand was. So you're looking at a very specific test case, which is given to us by the assignment, but it's a bit less generic than if we were to have a more varied world where you don't only have stone and like rock, sand, and empty space, but you could have something else. But like I said, the logic of your code is good. It would work. I'm just saying this so that we would understand how to do this. So let's try. We have the grid, and we need to change two things, like you said. The first thing we need to change is whatever's located at the second coordinate. In our case, we need to write y2, x2, because here we need to change them in places. And what we need to place there is whatever is located at y1, x1. So here, like the sand falls to the new location, right? And then the second thing, which is a bit easier to do in our case, we don't need even a temporary variable, because the next thing we need to do is we need to take whatever as y1, x1, and what's the value that we need to put there?
None.
Exactly. We don't need to take it from y2, x2, because it's always none. There is always nothing remaining there.
I get it. Now I know what you meant. Fine.
Okay.
Thank you.
Excellent. Excellent. So here we say the sand is no longer here, and we have nothing. And then the only things left to do, what's the last thing we need to do?
You have to return the grid.
We have to return the grid, exactly, because that's what it says here in the doc string. It says that it has to be returned. Return the resulting grid. And this is the entirety of the function. So now the function does what it's supposed to do. It's only 3 lines, and we can actually check it. How can we check it? We can import doc test. And after this function, we could actually run it. We could say doctest.testmod. And if we run this, besides the application, we will have an empty terminal, which means that our function works as intended. But we could actually check whether the doc tests are working. We could, instead of none, we could write something like empty space. Now we have empty space where the send was. And if we run it, we'll actually get a bunch of errors, which will say we were expecting none, but you have the string empty space, which is not correct, which is not the way this function is supposed to work. So as you can see, the doc strings are working, and if everything is correct, we have nothing in the terminal because doc test has nothing to report. So let's get this back to none. Does anyone have any questions on this specific function? Was it clear what we were discussing with Steve, or maybe you had some questions, issues, misunderstandings about this specific function? I'm mentally counting to 10 to give you time to actually ask questions. But if not, I propose we move to the second function, because at the moment, if we launch our program, nothing has changed, because we have a function which is not used anywhere. We still have send that's not falling. We still have rocks which are not falling as well, which is logical, but here nothing changed so far. So now let's take a look at the second function, which actually checks for a legality of a move. What we have here is the same grid. We have the same two coordinates, you know, from where and to where we're trying to move something. But this function is supposed to do a different thing. It should actually check the grid and tell us if there is a piece of sand here, can it actually move here? Is it a legal move? And there is a description of what a legal move is. And if the move is legal, we should return true. Otherwise, we should return false, saying, no, this move is illegal. And here's a description of a legal move. So a legal move, the destination should be inbounds, so we cannot go outside of the grid. If we try to go to the left of the grid or the right of the grid, or on top of the grid or below the grid, that would result in an error, and we do not want to get an error because our program will break. So the destination has to be in bounds. It's given to us that the starting point is in bounds. We know this. It says here the starting location is always in bounds, but the end location may not be. So we need to check this. The other thing, which is logical, the destination should be empty. So a piece of sand cannot fall into another piece of sand, or a piece of sand cannot fall into a rock. A piece of sand can only fall into something which is empty, which means it has the value none. And the third one is a bit more obscure. It says it's not violating the corner rule. The corner rule is if something is trying to move diagonally. So if we're trying to move something from 1, 1 to 2, 2, for instance, or from 1, 1 to 2, 0, so diagonal movement, this movement can be performed only if there is not a blocking corner to the left or to the right of the sand grain that we're trying to move. And once again, this probably sounds a bit like gibberish. So maybe let me try to, I don't remember, do we have a whiteboard here? Can I actually draw some, maybe annotate? Let me try writing. Okay, do you see what I'm writing on the screen right now?
Yeah.
Okay, cool. Can I choose, I wonder, can I choose colors? Yes, I think I can choose colors. So let's say this is our grain of sand. And I will use gray to, no gray. Okay, I'll use blue, like this is rock. For instance, I have rock here, and I have rock here, but I do not have rock to the left. So the remaining, for instance, this one will be empty, this one will be empty, and this one will be empty. So the question is this move legal? And is this move legal? So we cannot move here because this is rock, this is forbidden, according to the previous rule. The previous rule is it's not empty. So This one is legal, so this one is green. We can write this in green. This one is legal. It will fall in this direction, but it will not follow this direction because of the corner rule. The corner rule states that if there is a blocking rock here, you cannot go through it. So that's the hardest rule to understand among these three. This is what it means to not violate the corner rule. I hope this is more or less clear, but if not, once again, let me know right now and I'll try to explain it once again to the best of my ability. So now we have to, first I have to close this somehow. Okay, how do I get rid of this? Is there a way? Probably there is a way. Okay, there is an eraser, nice. So now we have to do this. And can someone, so I propose to do this checking one by one. I will even copy this. So I have this as a comment here to do the three things that we need to check for. So we need to check whether this one is in bounds, that's number one. The second one, we need to check whether it's empty. Third one, we need to check it's not violating the corner rule. So let's go through them one by one. How can I check that these coordinates are in, oh, let's start with the simple one. Let's start with the one where it says that it's empty. How can I make sure that that it's empty?
You want if grid
Yeah.
y2, x2
Yeah.
is not none, then return false.
Is not none. So the condition here checks whether the location where we want to move something, whether it's none or not none. Because if it is none, it means that it's empty and this one passes. But if it's not none, you could actually write it like this, but for reasons that I'm not going to go into right now, you see Python is sort of going like, oh, it's not a very good comparison with none. Do not do it with equality operators. This is done for reasons of optimization because this is actually a bit faster using the is operator. So if it's not none, it means there is something else there. It could be another piece of sand. It could be a piece of rock. And in this case, this move is illegal. And if the move is illegal, we have to return false. Yeah, we return true if the move is okay. Otherwise, we return false. So this is the first check we do. We check whether that place is empty. And we're done with this one. So now, how can we check whether x2 and y2 are in bounds? Because that's also a necessary component of this.
That's a little harder. But okay, so basically I use the Belyakov rule, okay, which is you
Whatever
write,
that one is.
well, I mean, there's many Belyakov rules, but one of the tenants he had taught me is you write the condition where it's true, okay, and then you just turn it into not
Okay,
in front of it, okay?
that's a good rule. I like that rule.
Yes.
That's a good Belyakov rule.
Okay. And so the condition in which your x2, y2 would be inbound, okay? And so you basically write the condition for which x2 and y2 would be inbound. And so if you're thinking of x2, right? Well, what I did was I actually defined two additional variables that's I call them max y and max x. And so max y is basically the length of the grid, and then max x is the length of the the grid at position 0. And so what that meant was max y is basically the total number of rows of grid, and then
Right.
max x is the total number of columns. of grid. And so when I went to write this condition, okay, I basically wrote like x2 has to be greater than or equal to 0, but less than your max x. And then y2 has to be greater than or equal to 0, but less than your max y. And then all of that, you just invert it and then change it into a not condition and then return false.
Okay,
I
so
don't know if that
basically,
made any sense, but
well, you made a lot of sense to me. I'm trying to visualize this as well to so that everyone understands. So let's say we have a very small world that has 5 rows numbered from 0 to 4 and 4 columns, from 0 to 3. So what Vicky is saying is let's make sure that we write a condition for something which is inside
are you
this.
hungry?
Oh, we don't know who is hungry, Vicky. We have no idea.
Let's see.
And then reverse this. So let's write a condition that it's actually inside this world. Yeah, Steve.
Okay, maybe I'm misunderstanding something, but isn't the maximum value for x the length? And for
The
y,
length
the
of
same
what?
thing? Of that, for x, it would be the length of, wait a minute, the
That's
length
the
of,
important question.
yeah, let me think, the length of grid y. No, wait a minute, it's wrong.
Oh, you're correct. Why? Why? You're correct.
Yeah, the
So
length of grid y are the number of elements in y, right? The
exactly.
number
So this
that
is
I'm getting
X
confused in my head with all these x's or y's. Yeah.
and this
Yeah.
is Y because this is
So,
done
yeah,
like normal geometry.
right. So
So
I'm
like
thinking
he
that,
was saying,
yeah.
the number of rows is the Y. So we have the maximum index for a row is 4.
So it's
And
the
the
length, right?
that's the length of grid. So this is
Yeah.
the length of grid.
Yeah.
So the question is, what is X? The length of what?
Length, the length of grid sub y.
Length of grid, and actually doesn't matter which one because they're all the same.
Yeah,
You
all the
could do
same. Yeah.
0
Yeah.
and it would give you wouldn't have to check
Yeah.
it each and every time.
Oh, okay.
So now, knowing this, we can write a condition, and our condition, as Vicky proposed, is if x is more or equal to 0, and x is less than length of grid 0, and y is more or equal to 0, and y is less than the length of grid, this condition would mean that it's inside the world. This is inside the world, but we need to check whether it's outside the world. And to do this, Vicky proposed to use the Belyakov rule, which simply state write the condition for the positive condition and then do this, not. This is a lot easier than writing the negative condition because negative conditions are notoriously difficult to write for human beings. Simply adding not to a positive condition changes reverses it, and it's a lot easier to do. So, and in this case, this means it's out of bounds. So in this case, we also return false. This is the second condition that we need to check.
Sorry, Alex, sorry for interrupting. It's x2 and x2,
yes, thank
right?
you. Sorry.
Okay.
Of course, it's supposed to be x2 and y2. I'm getting a bit carried away here. You are absolutely right. We're checking that one. And I actually not sure why is it underlined. Simplify chain comparison. So of course you can simplify it, but we're going to keep it as is. I'm sorry, PyCharm. I don't care for your comments. And now we have the third one. The third one says that it should not be violating the corner rule. So if we're moving diagonally, the side square should not be occupied by anything. So once again, for instance, let me do this with annotation to remind you of how this works. Let's say we are given this coordinate. This is the piece of sand that we're trying to move. And we're, for instance, trying to see whether we can move here. So we need to check whether there is a piece of rock here, or another piece of sand, which prohibits us from moving here. Or if we're to move, for instance, in this diagonal direction, these are the only two things that we need to check. Then we need to check whether there's a piece of rock or sand or whatever here or not. So how do we describe this in code? Any takers?
I think
I would be, yeah, Martha, go on.
I would think we'd use the we want to check whether the x2 but the y1 is none or not. So basically, the diagonal, we need to move over to where we want to move it to, but keep the same y.
You are absolutely correct. That is specifically what we would be looking for. So since we have two possible directions which we'd be checking, if we're moving to the left, we need to check the left side. If we're moving to the right, we need to check the right side. But before we do that, we need to actually check one more thing, because as you understand, theoretically, the coordinates x1, y1, and x2, y2 could be any coordinates in the world. So how do we narrow down to a specific situation that we want to check?
You want to check if y2 is greater than y1, because you want to first check to make sure that your sand is falling down, okay? And so if you have like y2 is greater than y1, that tells you you're definitely moving down, right?
Right.
And then if you're moving down, there is basically three possibilities. You can move straight down, which we don't care about in this case.
Exactly.
Or you can move in the two diagonal cases.
Right.
So you want to specify like y2 is greater than y1. And then you want to specify the two diagonal x cases. And so for the down left, that could be x2 is equal to x1 minus 1. And then for the down right, that could be x2 is equal to x1 plus 1.
Yes. So for instance, if we have here specifically x2, we're going to be checking x1 for this one and x3 for this one. But you're saying whether y2 is more than y1, I would make it more specific that it should be 1 greater than. So we're checking that it's actually falling to the next one and not any one in general. So I would go if y2 is equal to 1, so it's the next one, the next below it, and that means it's going to one of the three. Well, not one of the three, but all of the in the row below it, and then you need to check if x1, if x2 equals x1 minus 1. So here we're checking the left part, so we're moving to the left. In this case, the other thing we need to check, and the pixel directly to the left, we would say grid y1 x1 minus 1 is not none. So this would be one of the conditions for returning false. So let's go through this one more time. First, we make sure that the movement is down. It's moving from, in our case, in our example, from the first row to the second row. If that's the case, only in this case, we will check whether x2 is to the left of x1. So that's where minus 1 comes from. And the position directly to the left, if it's not none, so if this one is blocked, in this case, we return false. Otherwise, the second condition, as Vicky pointed out, is x1 is to the right. And then we need to check whatever is located to the right of the original, where the grain of sand is coming from. So in this case, we go y1. Oh, sorry, this is wrong syntax. The correct syntax is like this. And x1 plus 1 is not none. So in this case, we also return false. So if this one is blocked, we also have to return false. We cannot go diagonally. In all other cases, so if we passed this one, if we passed this one, if we passed this one, in that case we can only return true because there are no other limitations, and it means that all the other moves are legal in this case. So let me remove this. It's getting a bit more difficult to read. And we can now actually check whether this function works as expected by running a doc test on it as well. So we will run a doc test on everything that's above it. And we have a bunch of errors, which is good because now we can check, where we have the errors. So for instance, here we have a failed example. Let's see how many we got correct. So we only have 2 failures out of 9. So we checked 9 test cases, 7 test cases worked correctly, but in 2 cases we had some errors. Let's check what they are. For instance, one of them, a failed example, says that we're trying to access a index which is actually out of bounds, and we get an error, and we have to understand why we're having this issue. So remember that here we're checking in whether it's in bounds or not, and we have this error. And I think something here it's the same. We have the same issue. We're trying to go somewhere which is out of bounds. So we have an issue with checking the x2, y2 coordinates. Let's take a look of why this is happening. So we're checking this has to be in, this has to be smaller, this has to be smaller. Is this the place where you get there? Sorry. Which line? Line 52, and here it's line 54. Oh, it's giving me the specific ones. So x2 length of grid, so that's the x. x2 should be smaller. Is this enough?
Alex, excuse me. I don't know, because that seems right to inbounds. But when you're doing that, not violating the corner rule, and you have y2 is equal to or equivalent to y1 plus 1, couldn't that send the y out of bounds?
It could actually. You are right. Let's think about it for a while, whether this could actually be the case. Let's try putting in a failsafe. I think you might be right. So if y2 equals 2, so we're not doing anything weird here. So this one could trigger and this one could trigger, right? So if we are moving to the left, we need to check that and x2, okay, let's go. So that x2 is more equal to 0, and here x2 is less than the length of grid 0, something like this. Let's see whether that still triggers a problem. No, it still does. Let's take one more time a look at the specific one. So this is the one that triggers the first one. We have 0, 0, 0, 4, and y2 is out of bounds. So let's go. First, okay, of course, the reason why this is happening is because, remember, I changed the order in which we're checking, in which we're making these three checks. And the problem is that I'm checking whether something is in or not before checking whether it's still out of bounds. So there was a very particular reason why it was in that order, and I decided to change it, and that was not a very good idea because we ran into this issue. So let's change it back. We are first going to check whether it's in bounds, and only if it's in bounds and we do not return false here, we're going to check for emptiness, and then we're going to check the corner rule. So let's run this one more time, and there we go. There we go. That was the problem. That was the issue. The order is important here. And now we have basically two functions. And now what we're going to do, because if we run the program right now, we still don't have anything happening because we're not using the functions that we just wrote anywhere. But the next one, which is do gravity, actually changes what's happening on the screen. And what it does, it gives you a coordinate on the grid, and it says that you need to check if there is sand at that coordinate. We know that it's an inbound, so this is given, it's an inbound coordinate. We don't need to check whether it's legal or not. If there is sand at that coordinate, we then need to make one move, either down. If we cannot move down, we want to move down left. If we cannot move down left, we need to move down right. And after we do this move, we return the case, the grid, sorry, we return the grid, and we have a number of tests here for different movements. There are a lot of tests. So, and here's where we need to use the previous functions that we just wrote. Because basically, we're trying to do the following. First, we need to check whether the direct downward movement is legal. And in order to do this, we need to call our check move function. We have the same grid, obviously. We're checking the same grid. The initial coordinates from which we're trying to move are given to us as x and y. So these are the ones that are given to us as parameters to this function. So can someone help me? If we're moving down, what are the destination coordinates as compared to x and y? I can't hear you, Steve. I see you talking, but your mic is off.
I was talking to myself.
Okay. So
but maybe x and y plus 1, I don't know.
Exactly. Yeah, you're absolutely correct, because moving directly downwards is increasing y by 1 and keeping x the same. So if we check this move and this move is legal, we need to call the other function, which is called doMove, and move from xy to xy plus 1, and that's that. However, if the first check move is illegal, it means it returns false. We need to check the second one. And which one is the second one? Which direction are we moving if the straight downwards movement is not good? So from xy, where are we going? Remember, we need to do a down left movement. So if we want to check the possibility of a down left movement, what would the coordinates be? Anyone?
Is that the x minus 1?
And y?
Minus 1?
Y minus 1 would mean going upward because,
Oh, right. So y plus 1.
yeah, because the axis is inverted.
Yeah.
Yeah. So now we check whether we can go down left. And Demetrius, you're absolutely right. I see you writing in the chat the same one. And then if this one is legal, we do the same move. So now we move x minus 1 and y plus 1. And the last one is if we can't move down and we cannot move down left, we need to check whether we can move down right. And in this case, from xy, we're moving to what coordinates?
X plus 1.
And y also plus 1. And if this one works, we also do this, do the move to x plus 1, y plus 1. There is one thing missing here. So this logic is correct, but there is one thing missing here, which is required by this function. Can someone tell me what's missing?
If you have no legal moves, you just return the grid as it is.
Yeah, but what happens if I do have a legal move?
Oh, if you have a legal move, you would then do move, right? And then if you do move, you would call a subfunction of do move, and then I think do move returns the grid.
Yes, but it returns to grid to the calling function, so it returns the grid to do gravity. But we need to return the grid in all cases from do gravity. So it's not only returning the grid if there are no movement, we actually have to return the result of all of these three functions back to the calling function. So we need to try return here, return here, return here. Otherwise, we simply return grid in its unchanged state. And
really?
now
Oh.
we can test it once again and see whether this one has any issues. And as you can see, it does not. But yeah, I promised some changes, but no, there are still no changes. There is nothing working because we have a function to work on a single grain of sand. But now the last thing we need to do, I'll skip do Brownian because this is not necessary. We need to do the whole grid. We need to apply this specific function that we just wrote to each and every grain of sand on in our grid. So we actually need to go through them all and apply. And it's not written here, but if you were to look at the actual assignment, the doc file, which Vicky put on the Google Drive, there would be an explanation that you actually have to start from the bottom row and then go up. So you first have to check the bottom row, then the row above it, then the row above it. So in reverse order. So this is coming back to looping over the entire contents of our grid. How do we loop over a 2D list? Can someone remind me how can we go through each element and call each element?
You could do like, you could do like for y.
Okay, for y.
Okay, it's actually easier to write it as the standard loop. You could say for y, in like range, I define like a max y, which is like the length of the grid. But you could also write like for y in len grid.
Okay, so that's the starting point.
However, because you want to reverse it from bottom up, right? It
Yes.
specifically said in the assignment there is a reverse function. And so you would write the loop as it is, okay? And then just add the reverse in front of it. And so it would be for y in reversed range len grid. Yeah.
This is one way that you could do it. The way I did it, I did not use the reverse function for the simple reason because you can use the 3 parameters of the range function to do it inversely. So if you want to go from the maximum to the minimum, you could put the start parameter here, then the end parameter here, and the step here. The step for reverse would be -1 because you are going like from 10, 9, 8, 7, 6, so that's -1 to previous number. And the question is, what is the first, what is the last index that we want to have in our Y?
0, right?
0. But remember that when you use range, you have to put here a number which is excluded, because if you put 0,
Oh,
0 would not
and
be
so it would
included.
be -1?
Yeah, it would be -1. So this will do the same thing as reversed, but you could
This is
use
too
reverse.
complicated. I think reverse is easier. It's conceptually easier.
No, it's not conceptually easier. It's easier because you don't want to understand how it works. But this actually helps you understand what's the logic between going in reverse order. Okay, so here we're correct. And now the inner loop.
Well, and then for the inner loop, okay, and so for the outer loop, you're looping over the rows, right? And then
Right.
for the inner loop, you would be looping over the columns, and so it
Yeah.
would be for X in range.
Yeah.
I think it would be len grid 0.
You could use 0 here because they're all of the same size. Yeah, so you don't need to do Y, you could do then grid 0.
Wait,
Okay,
sorry, Alex. So what if I don't specify a number? What if I just said len grid? Would that work?
only for a square grid if Y is equal to X. If it's a rectangular grid, you would have either a problem of overflow or just working with a part of the grid. We could actually check it and you'll see, what happens.
Okay.
So, okay, we have the X, we have the Y. What do we need to do with those two coordinates?
And then you call your do gravity function.
Exactly. You say do gravity grid for X and for Y. So basically you're iterating over each and every grain of sand, but there is one important thing that we need to do, because if we run it like this, rocks will start falling as well, which is not something that we want to do, because we want to make sure that only sand is falling. So what do we need to add here to make sure that this applies only to sand?
To sand. You want to set it to a variable grid?
Why? Like I have the grid, or hold on. Maybe this has to be done in a. Okay, this is something we had to do in do gravity actually. So our do gravity is at the moment incorrect, because here we just apply it to everything. But in do gravity, we need to make sure that the whatever is at x, y is actually a piece of sand, and we haven't done that. So we need to add a condition here, and the condition would be if whatever is at grid at coordinates
Is equal to
y,
S.
s is equal to small letter s, because that's how sand is defined in the grid. Only then we do this. Otherwise,
Yeah.
we still return grid even here if it's not sand, but yeah. And now this should work regardless of what Brownian is, because at the moment we don't care about Brownian. Let's see whether this works. Doesn't. Where do I have the error? List index out of range. XY, YX. Why is it out of range here? Grid YX. Okay, it seems that for some reason when we're going through this, we are going somewhere out of bounds. into gravity, do whole grid, yx. Why is it going out of bounds? We're starting with the oh, okay, we need to start with the len grid -1. This is an issue. We're trying to start with an index which doesn't exist. So let's do this again, okay. And now, suddenly, we have sand falling from the sky, because for every piece of sand that I'm drawing on the canvas, we are applying gravity to the sand. And now I can actually draw some rock and see what would happen if it's not just free falling sand, but we actually have some holes in here and crevices. And if I start doing this, you'll see that it actually gets stuck, but then in some places it starts diagonally moving and falling through the cracks to the floor below. And basically you have a working program here. So you have sand falling slowly like snowflakes and filling up, whatever's below. And this is actually the working program. So we were working on functions and nothing was working, and then we suddenly put them all together and we have, sand falling from the sky. And the only thing that's not happening right now is the Brownian motion, for the simple reason that we didn't implement the function. So now everything is very, regimented. It happens like this and no other way. If you actually implement the Brownian movement, it will be a bit more chaotic depending on how much you set the Brownian movement from 0 to 100. Andrew, I see your raised hand.
Yeah, could you just go over what you did when you added that -1 to, I think it was line 160?
Yeah, like this one.
Yeah.
Sure. I took len grid. So for instance, if our grid is 20 rows, has 20 rows. So len grid would give us 20, correct?
I'm sorry, say again?
So if you have 20 rows and you use this function, the resulting answer would be 20. Well, that's because what len does. Len gives you a length of a list.
Right.
Okay, so this would give us 20. But the problem is that if you have 20 rows, what are the indices for those rows? Like, what's the index of the first row, what's the index of the second row, and what's the index of the last row?
0 to 19.
Exactly, they are 0 to 19. So when I had this written without the -1, I actually tried accessing index 20, and index 20 does not exist because we only have indices from 0 to 19. So I actually have to add -1 to start from the 19th index and then go backward. 19, 18, 17, 16, and all the way to 0. Does that make sense?
Yes.
Okay, cool, excellent.
Which is
So-
the reverse is easier because you don't have this problem.
Right, but the reason I did this is because here at least you understand how it works. When you do reverse, you sort of go, la la la, I don't understand how it works. But you could have used reverse. So you could say reversed range len grid, right? Is this the way it's supposed to be?
It's okay. I will share my code using reverse if people want to look at it with all the comments. And then I also have the Brownian working, I think. So,
Sure.
so you can look at that.
Yeah, so given that we're already half an hour past our, deadline, I will not be doing Brownian now. It's a rather simple function which uses the random randint function to generate a random number and see whether some piece of sand moves according to Brownian motion or not. So like Vicky said, she'll provide you with a working function if you have trouble writing it, so that you can have the entire program. So that's it for today, or for some of you for tonight. And the fun thing about it is that you actually write code, you put it all together, and then you press play, and suddenly all of this starts working, and you go like, wow, nothing worked. And then at some point in time, when we did, you know, all the functions, and we actually checked all the functions, we could go doc test mod and run it. And once again, we'll get, hold on.
Alex, I actually have a question regarding your code for the function do whole grid.
Oh, it has to return something. It doesn't return anything. So that's, I think, an issue.
Well, yes, you could just type return grid there. The other question I had is because in the test code, in the starter code, okay, if you look at the do whole grid, the parameters you're supposed to give it is actually grid and Brownian. And so in the code that you wrote, it doesn't contain Brownian. And so is it still gonna work?
It's still going to work because Brownian is actually passed to it, but
Okay,
it's
but
just
it's not used in any way. Okay, got it.
exactly. So we're not using Brownian, so the function doesn't care whether, you know, what the value of Brownian is. That's the difference. Okay, so that's it for today, ladies and gentlemen. Thank you, as usual, for sticking until the very end, and I hope this was helpful and enlightening. If there are some questions that you want to ask right now, I'm ready to answer them, but otherwise, if not, then we're done for today. And a reminder, next week it's going to be Chris doing the data science case study, putting together all of the information that you've learned previously. And I will see you next time in 2 weeks, and we'll discuss strings. So that's the plan.
Thanks, everybody. Vielen Dank, Alexander.
Vielen Dank.
Thank you so
Bye-bye.
much. This is great.
Thanks so much.
Thank you. See you next
Thank
time.
you.
Bye-bye.